Welcome to today's Dlubal webinar. My name is Walter Rustler. Today's webinar is about the BIM workflow using RFEM and Revit structures. We will learn about the BIM integration with Revit structures. We will see the import and export scenarios, and we will talk about update mechanisms. In 2004, Autodesk asked us if we would be interested in develop a seamless interface to a new product called Revit Structures. We were excited about this and right away agreed that we would cooperate. And in the same year, we created the first version of the interface. It is a bidirectional interface based on APIs. We are not using any file for the exchange. Both applications, RFEM and Revit Structure, communicate directly. This means that we will not work with files, but we will work with direct communication between both programs. The interface is part of any standard RFEM RSTOP license at no extra cost. The covered BIM scenarios are following. A, we can export a Revit model to RFEM, and we can also import an RFEM model from to Revit. That means we can use the analytical model which is in Revit and export it to RFEM, which is a great benefit. Not all CAD applications give us this chance. In many cases we have only the physical model, but Revit has the advantage that we have in there also the analytical model that we will see shortly, and we can directly derive a mechanically usable analytical model and start the calculation. So the dominant way will be to export the Revit model to RFEM, but also in RFEM we can create large models pretty fast, and this work should not be lost, and also it is helpful in many situations that we use it then in RFEM for further creating of plans or for doing some cost estimation. Or Revit is also a good access point to other Autodesk programs like AutoCAD and other CAD programs that base on AutoCAD. So once we have the model in Revit, we can most likely also use it in various other programs. So this is why we also implemented the export from RFEM to Revit. In the interface is also covered the update of changes in both directions. That means that we can make changes. For example, in Revit we can add beams, columns, surfaces and so on, and we can update then an existing RFEM model with those changes. Changes are constantly happening in today's planning world, and therefore it is important that we do not have to start from scratch when such a change happens. We'll also see this pretty soon. When we exchange the data, we talk about walls, slabs and foundation slabs, including openings, beams, columns, bracings, and also we can handle eccentricities. All those objects are created, for example, in RFEM, and then we take them from there. For the typical statical objects, stand supports, releases, or rigid links, load cases and load combinations. We cover point loads, line loads, and area loads. When we talk about material exchange and cross-section exchange, we have two different programs. Most likely they have two different names for the same material or for the same cross-section. So we need mapping files that link the two different descriptions or names of the cross-section, so it's unique. We also have included those mapping files, and in Revit you have so-called families that you can name as you like, and with this naming you also have some options to create families that are compatible with RFEM or Dlubal software in general. Before we start the live presentation, I'll also would like to introduce my colleague Lukas Sündl. He is with me online today, and he will assist me in answering short questions that you can ask in the questions toolbar. Please keep the questions short so we can briefly answer them. If we should not be able to answer them during the webinar, we will follow up by email. In the live presentation, I will start with a simple model and show the exchange options, and then go to more complex models and show you both scenarios from Revit to RFEM and from RFEM to Revit. I have Autodesk Revit open already, and I've prepared this first example that I'm going to open now as well. In the background I have also RFEM open, but there is no file opened yet. In Revit, we see here a simple model consisting out of columns and beams and some foundations. I can show the wireframe representation of the model, and we see here the physical model, which are the beams and the columns as we know them, the eye shapes, the eye sections, and we see also the analytical model, which is laying below this or behind this physical model. You can show this analytical model here, and we see that we have here a simple stick bar model, including the analytical nodes, and the beginning and the ending is shown in different colors. So we know when we click on it, we can see at the start we have different options than at the end. But let me start with the regular representation, and I will explain a little bit how this model works in Revit. Each beam or each member I can select, and typically there is a dialog with properties, and I can arrange or align the geometric position of this cross-section. I see the cross-section name. I can also say, okay, the geometric position in direction C should not be top, but also maybe in the center. You see the cross-section moves upward. You see also that the analytical stick model stayed on the same position. So we have an independent way to model the physical representation and the analytical representation of the model. You can also, when you select the member, you can also enable or disable the analytical model completely. So if I uncheck it, the stick model for the analytical representation will disappear. So when we export the model to RFEM, we only take the analytical representation of the model. And for example, if the analytical model is disabled, like here, it will not show up in RFEM. So this way you can define which parts of the structure that are of interest for the structural analysis will be exported and which ones will stay in the Revit model. Important is when we update the structure later, we do not change the alignment. If there is a new beam imported from RFEM to Revit, it will also always have center alignment because we don't know how we really want to have it in the real world. In Revit, the user can then adjust it. We'll see this also live later. For me, it was important to point out the two different models and show quickly how you can emphasize them, how you can change them. Also, maybe I make one more change in the analytical model. In the analytical model, there are different properties. Here we deal with typical analytic properties like structural, like start release and end release. If I change it, for example, to pinned, then I will get a different release at the beginning and the ending of the member. Or we have also here the analytic alignment. So independently from the physical model, I can change it. For example, I can say the end alignment should be in the center of the element or on the top of the element, maybe center. You see it moves down. Yeah? Here I would have, maybe I change it to the top. And if I can also bind it to a level that I have defined in here. Yeah? You see here that it can happen that there is a gap between the two nodes of the top or the horizontal girders and the cross beam here. I can fill this gap with a so-called rigid or analytic link that I can manually also enter in Revit, and it will then also be exchanged with RFEM. So there will be a rigid dummy member that connects those two analytical nodes. So if you want to have really those eccentricities and those gaps of members filled, then you can use analytical links. In some situations also the analytical links are made automatically inside Revit Structure. Okay, let me maybe go back and start with the original representation of the model. And I go back to how I started out. I think now we are okay. And in the next step, I will then export the model to RFEM. First, I would like to display the wireframe representation so I can see both models in a little bit better way. Here you see also foundations. Revit has a footing object that we do not have in the same way in RFEM, but typically structural engineers model those footings as a support condition, like an isolated support, and we can do this automatically and convert those footings into isolated supports. There are different options I'm going to show you. When we start the interface, we find here a Dlubal menu, and we can export and import the model to RFEM or also to RSTOP, which is the more simplified version of RFEM that deals only with members and columns but has no surfaces and solids like RFEM does. Okay, the interface is part of the standard RFEM installation, so it comes at no extra cost. If you would like to install it, all you have to do is install RFEM, important is that there is already an existing Revit installation. So during the installation process, RFEM can recognize that there is Revit and it will automatically install the plugin. So if you don't have it, just reinstall RFEM and it should be available. When I export the model, I get a simple dialog with different settings. First of all, we have the option to change direction of the global Z-axis. By default, in Dlubal it's downward. We can say if we want to create a new structure, if we want to override an existing structure, or updating an existing structure. As I said briefly before, export to a file is possible without a license, but you still need a version of RFEM installed on the same computer. You can download, for example, a trial version, export the model, and then instead of seeing the model in RFEM, you get a RFEM file that you can hand on to any RFEM user that has a license. So in this way, Revit users are always able to export or to give a RFEM file to any RFEM user that has a license to work with it. I can define if I apply member eccentricities or surface eccentricities. I can choose if I only want to export selected or only visible objects. And there are some other options I'm not going to explain at the moment that can handle more detailed situations. In the structural settings, I can define whether I want to export only structural data or if I want to export also loads. And because Revit has no automatic load calculation from the weight of the structure, we can, and there's no option to define in which load case it should go, we can set this option by this check here and assign a load case where we want to have automatic self-weight applied to. So all the modeled structure in RFEM will then have self-weight properties, and it will be going into the analysis. Also, we can export combinations and groups to RFEM. There are two important checks here where we can convert isolated foundations to either a nodal support, which is a pin support, or to a surface with elastic foundation. So we're talking now about those supports that we see here in the background. And same thing is valid for linear supports. If we have wall foundations which exist in Revit, we can create automatically linear supports from it. I'll show you this quickly, and I also show you the eccentricities of members and the difference if we export it with or without eccentricities. So I start the export. We see a short protocol. All the changes are logged in a log file that can be used to track down problems or to find references between IDs in Revit and between nodes or members, lines, and so on in RFEM. So this is a helpful file for several for different information that we can use in case we need to clarify some things. I go to RFEM and I see in RFEM I have my model, and instead of a support we have here a elastic slab, elastic bedded slab that has here some default settings for the springs for the support conditions. So you can change it anytime you like. In fact, you should check those conditions before you keep on calculating. We see here also, we have here releases. If I edit the column, you see here there is a member and release which comes from Revit. So all these properties come from Revit. We see the cross-sections have been converted. The name in RFEM is IPE 360, and in Revit it was written without any blank between IPE and 360. So we take care of it using those mapping files that you find at import or export, detail settings, and here you can edit those mapping files. You can also export, import them to Excel. So if you'd like to edit them in Excel, you may do this here. The same is valid for the materials. You see here in Revit, the material is just simply as 335 JR, and in RFEM we also implement the code and we add the code designation there, so you can directly reference which material you want and also export input to Excel. This model here, if created correctly in Revit, you can run, you see we have here 4 load cases. There are no extra loads besides self-weight, and we can run the analysis, and it's a mechanically working model, and we see here deformations, we see here internal forces, we see here also results for the foundation slabs. It's clear also that you may not be able, or it's maybe not such a good idea to model such situations like slabs, and there's a column with just maybe one node connected to a slab. We cause singularities. You can change the model as you like. It is a totally independent RFEM model at the moment. You don't have to update it back to Revit. It's just a regular RFEM model. So there's no limitations. It's just as if we would have modeled it manually. Let's take a look at the eccentricities. We see here the structural or the analytical nodes have been taken over from Revit, and all the members have been put eccentrically, so we have top alignment on the flange, on the top flanges. Okay, I can do the same thing again with different options. Export model. I do not apply member eccentricities, and I say please use nodal supports, and I can just update the model. And if I go to RFEM, then I have a more simplified model with isolated supports, and all the beams now meet centrically, center lines. It's up to the user whether he wants to work with or without eccentricities. If I run the analysis, I get slightly different results, of course, because everything depends then on the model. Okay. Typically, then we do some changes. We do the structural analysis, structural design, and this involves changes. We might need additional beams. We might need additional columns. We may change cross sections. I'm not going to do a full design procedure now here inside RFEM. We have several other webinars that you can find online on our website, where you can see this in all details. But I'm doing some manual changes here so we can follow the update procedures and demonstrate them. I'll just make a copy or a couple of copies of this beam here in a distance of 2 meters, and we have here a couple of intermediate cross beams. Maybe I want to use a different cross section for it, and I create a new cross section. Let's make it pretty high so we can see the difference. Okay, And maybe this is the result of my structural design, that I need a different cross-section. Maybe also the result is that this column here and this one should be rotated in the other direction because there's a bigger load in this direction, and maybe it should be also a different cross-section. Maybe we want to use 300 for it. This is a result of the structural design. Because I changed the entire cross-section, this means that also all the other columns that use the same cross-section use also the same. I have also now the AGA 300 cross-section. So what I did, I added a couple of members, I changed the orientations and changed the cross-section. So when we're going back to Revit, we have to update those changes. So I import the model, and I can just say apply changes, and I remove I update the existing structures, and I start the import option. So now Revit and RFEM communicate, and all the model parts are compared, and I get here the updated model. And we see here we have the new beams, we have the changed orientation of the column. When I select it, we see it's a 300 size column, and everything otherwise, like the alignment of the beams, of the original beams, stayed the same. And here, because these are new beams, we don't know how the Revit user wants to have them aligned. I can do this now manually, just by selecting both cross-sections, both beams, and change the justification maybe to top. You see also the analytical model moves with it because it's set to center, but I can also say here I want to have it either on top, or there's an auto detect function in Revit for the alignment, and if I do this, it will be moved to the next horizontal cross beam and will be connected there automatically. The same way I can do changes in Revit. If I go to the top view, maybe I want to change the distance here from 6,000 to 5,500, or also the distance here from 6,000 to 5,500. So Revit has a nice feature that you can automatically move those columns and so on in the model. It will actually, if the let's do it one more time. Let's say 5,500. If you change the grid, and if the columns are linked to the grid, which obviously is not done here, you will get the cross sections move automatically. So now I have to see what's wrong here, because it should be centered, and this moves with grid should be part of the grid. So while it is moved, it should be moved to the grid. So I have to move it now manually. This should not actually happen for whatever reason. Okay, go back. Maybe I move it manually. Let's say I can change those cross beams here. I can say I change them to 1,750. Yeah, and I can also change this to, maybe make a different change to 2,500. Yeah. So also maybe somebody wants to have a different cross section here. We can assign, for example, 270 for whatever reason. Maybe it's a cheaper one to get it's cheaper to buy it. I make those changes here, and I can, as the same way, I can update the model then to orphan. I keep the standard settings as I had them before, and I start the update procedure, and you will see then that everything is changed here. We should have a different cross section here. If I edit it, it's a 270, and this one was a 200, so it's bigger. And we see also here the distances should be changed. I can make some dimensions here, which is 6 meters, but I have to select the nodes. Here we have 1750, and here we should have, that was the wrong node. Here we should have 2 meter 50. Yeah? So all those changes have been carried out. Okay. Another important thing is what happens if I don't want to take over the entire model. Maybe I only want to take over part of a model, maybe just a level. I don't want to have a 3D model. I can also do this. I can select part of the structure. I say export, and then I handle only selected objects. The same way would be if I only create a visibility of certain objects, only display certain parts, and I can only refer to visible objects. That will be a similar setting. This time I create a new structure. If I do this, then we'll see that there is only this level, the grid of this level. Yeah? Let's say I can do this the same way, for example, with one frame only. Yeah? When I say OK, Dlubal, export, only visible, only selected object, I create a new structure, and I'll get only here this one frame. Let's say there is a change, and I want to, maybe I close this one. And in my design now, I find out that those beams here, they can get by with a smaller cross section. So I can change it to 300 maybe. And now I want to do an update from this model, which is only part of the entire structure. How to do this? I go to Revit, and inside Revit I can import the model from RFEM, and here's a setting that's called Remove Absent Objects. So if any part that I see here in Revit is absent in the RFEM model, it would be removed. If I uncheck it, we keep all the parts that cannot be found in RFEM, we keep them inside Revit and only take the ones that we find in RFEM. So Revit or RFEM compares two models, and we see, okay, there is a cross beam that has the same internal ID and that has a change cross section, and I take the change cross section, but I cannot find the column in the RFEM model, but because this check is gone here, I'll leave it there, no matter what is there or not. So if I do this, import, and I start it, now I have to decide which model I want. I should have saved the first model under a different name, so it would be better to distinguish, but I need to use the second model because it was created after the first model. And if I do this, we'll take the changes and it will update my cross section. You've seen it has changed. It will update my cross section without touching the rest. And also please note the alignment of the structural model and the top alignment of the physical model have been unchanged. So those are important things, important concepts to understand. So you do not have to work with the entire 3D model. You can use one slab, one level, one frame as you like. You can split your model into different parts. You can also, if you want to, you can also add entire buildings into one complex Revit model. Or you can, if you have a complex Revit model, you can export only one building to different RFEM files. So you have the option to combine those methods. Okay, this was the first simple model. Next, I'm going to show you a different model, different smaller model that has some surfaces or slabs in there. I open the second model here, and I'm going to show you here some new things about how to handle floor beams or beams that are eccentric in Revit or in RFEM. We see here a simple model with two slabs, several columns, and it has different loads in here as well. We have horizontal loads and vertical loads, and I'm going to export it to, here we see also in Revit we have support conditions, and these support conditions you can as well edit already in Revit. You can assign individual linear or point supports, or also surface supports, and I'm going to export it the same way as we did before. Export model, we create a new structure, we also include loads, and we run the export. So a new model is created in RFEM. Since we have here also loads, we can right away work with it. We can take a look at the loads. They are all here. You see here area loads, snow load, live load, wind load, for example. There are no combinations. There's only the basic loads here, and inside RFEM I have powerful options to create combinations according to different standards. I use here Eurocode, and I want to create combinations automatically. So if I do this, I get additional tables here in the loading, and I have also the option to assign actions, and also to decide which design situations I would like to use. You can do it in different ways, and I want to use load combinations which combine the loads according to Eurocode in this way. So we have factored load cases. Okay, I can run now one of these load cases, for example, or load combinations, to check if the model came in from Revit correctly. And we see here we have a nice deformation plot, but there is also a problem because we have a large deflection here. So how typically we want to fix it? We want to say, okay, maybe I can get by with a less thick surface, but instead I would like to have a cross beam here that strengthens this long gap where the column is missing here. So for this I'll just enter here a line, and I make this line into a member, and I assign a new cross section. I use again a pretty large cross section, so we see it clearly in the Revit model. And here I check then rib. And RIP is something which aligns a cross-section or can align the cross-section just underneath the surface slab. So the eccentricity is calculated automatically. And also I can assign the RIP a integration width. So the internal forces of this cross-section that I'm going or I can design later is integrated from part of the slab internal forces and the beam internal forces. So it is a special procedure that we need for design of this member. When I do this, you will see that in the rendered mode that the cross-section, the beam is underneath the slab. There's a small gap because we don't show by default the thickness of the slab, but it's now exactly underneath the slab. Okay, and at the same time I also would like to enter here an opening. For this I need to set my grid into the right level, and I can create a simple opening here, something like this, for a staircase maybe. Yeah? So I made actually three changes. I inserted the beam, I changed the thickness of the slab, and I also made the opening. How to exchange those things? Again, the same way. We import the model from RFEM. Now it doesn't matter if I remove absent objects. Structural settings I can leave as they are. I start the import. We compare both models internally, and after a short time we will see then the updated model inside Revit, including the combinations. That's the first change I did. So we see here now the opening. We see here also there is the extra beam in here. I can also maybe select the floor, which is now 160 millimeters. We can see if the beam is correctly placed under the slab. If I go into a view, you see here the beam is here just underneath the slab. I can also check it if I put here a dimension line. You see here exactly 800 millimeters, so it's exactly the height of the cross-section that I created. Also, I can show the imported load combinations. You go to the Analyze menu and you see your load combinations, and you can show the third-party generated load combinations, and they're all in here, and you see here there are the safety factors that RFEM created. So you do not have to do it manually here. You can use the tools of RFEM to create the combinations and import them. By the way, you can also do this. When you import, you can also just import loads. So you can uncheck the structural data, and only the loads will then be imported. So maybe you say my model is correct, but I need the load cases and the loads. You import only the loads. Okay, this was the second model. Now we have another model. We go a little bit more complex now. I close this simple model here to avoid any confusion with where we exchange data with. So I close all models and we go back to Revit, and here I have a more complex model with 3D steel structure and concrete structure. You might have seen this model already with a different webinar that I did earlier, where I showed also the design of Eurocode a little bit more in detail. This is now here fully modeled, including loads and load cases. We have here snow load, wind load, lateral load, support conditions. I took care of the correct alignment of the stick model in RFEM. The releases are set, and now we can use this model and we can export it. Maybe I should hide the analytical model here. We can export it to RFEM, run the calculation, and then do a short design and update maybe some cross-section. So this could be the scenario of this conceptual design. So how to do this? Dlubal, export model, create new structure, apply loads. We assign self-weight to load case self-weight, and we start the export. Everything seems to be okay. We go to RFEM. We have here the entire model, including supports, including releases. We can show the loads. We can see the wind loads. We can see the live loads, and the combinations as well, because in this RFEM file I had also combinations. Okay, I can now maybe quickly, or one thing I have to do, because this is not possible in Revit yet, I'll select all my bracing cross sections quickly here and change them to beam type tension or member type tension. As you can see here, we have many different settings, many different types of members that an application like the BIM software Revit does not have yet. Maybe it will have in future, but there is many other things that is part of the structural design that is not included in Revit at the moment, and maybe also not necessary. So it's up to you whether you have to pack everything into Revit, or you may find everything there that you need or not. But anyway, some changes might be necessary, and one of it is the tension only setting that I do here. And now I go into our Eurocode 3 design module. Maybe I take care of the Eurocode design of the beams quickly. For now, I do just a brief conceptual design. I use, I go to the cross sections and I check a couple cross sections for optimization. So I want to optimize my main beams and columns of these main frames, and I will pick the right IPE cross section, hopefully, and I run the analysis. So now the RFEM analysis should be starting, and we calculate quickly those combinations. So you see there seem to be no problems in the analysis. Everything iterates, so it's a fully working model. It will take a few seconds now before we can do the optimization in SteelEC3. This procedure, this scenario is not something I'm just demonstrating here today. It is done by several customers of ours that have developed ways. They only work in Revit, they only develop their original models in Revit, derive their quantities from the Revit model, make their drawings, and then they want to have a quick design after a change in Revit. Maybe they only want to have foundation forces, do some preliminary design of foundations, so they can quickly derive this from such analytical models and are always up to date. So this is something I can really see taking off at some customers now. And this is also why we are doing those developments together with Autodesk. It's also possible, for example, when we have concrete design, that we export then reinforcement to AutoCAD structural detailing. So there can be done a analysis or a plan for a wire fabric for reinforcement and so on inside Autodesk structural detailing, for example. No? Okay, now we have results. We see here the design ratios. We can go back to the cross sections and we see here blue the different cross sections. Now the optimized cross section. We used to have IPE 600, but 400 would be okay. So now I say this is fine. I export all the cross sections to RFEM. Of course, results will be deleted. And then I have here my change cross sections. And this cross section, I'd like to, now everything is checked. Let's say everything is fine. This changes I need to update now in Revit Structure. So I go back, I import the model. This time I don't need the loads because I don't want to change them. I just want to update my structural information. Those programs communicate again, and after a short time we should see the changes here in Revit as well. So it's now writing members, and if I go here I should click on it, and then we see here IPE 360, and here we have IPE 400. So all the changes are done, and also if I go back to the analytical model, I see still here my loads and everything is still there. Everything is okay, and if I want to export it again, I can do it the same way. So this was scenario 1. And the final scenario I'm going to show you now is when we start a model inside RFEM. For this I create a new file here in Revit. I'm using a template that I have prepared for it. That includes all the cross sections and everything I need that are compatible with Dlubal. And in RFEM I open another model, which could be this one. And let's say I have done my design for this building here in RFEM, and now I want to do I want to create a big plan with some views of the building, some explanations that typically a structural analysis software may not have this capability. So I go to Revit, Dlubal, import model. Okay, I can also get my loads if I want to. Now there is no model yet in Revit. Everything is empty, and I can save a lot of time modeling in Revit if I can use the existing RFEM model. There are some messages. If we cannot read something because it's unknown or not compatible, there we will display a message. For example, we have result combinations which Revit doesn't have in the same way as we do, so we just leave them out for now. They are not included, and you get a warning here. So, but the rest is here, and you see here there is the 3D model of the structure with all the openings, with all the round corners and everything, and we can go from this in Revit. For example, what I can do is I can create a new plan, a new sheet, A1 metric sheet, for example. Maybe I want to have the 3D model displayed here. Maybe I want to have the east view here, the north view maybe down here, the south view next to it, and the west view here. Now I can move this now a little bit in the center so I know how much room I have. Maybe I leave this here. And I have a nice drawing that I can print out, give to my structural engineers to explain. I can write there. I have all the options that such a BIM software like Revit has. Okay, this concludes my presentation. Before we separate the before we finish the webinar, I'd like to give you a little bit more information. If you have further questions, please visit our website dlubal.com. You find here quite a bit of information. Also, we have a website that is called BIM Planning that has information about this interface and also especially the Revit interface and other interfaces that we have. Dlubal is very active in BIM. We are a member of Building Smart, and we have been the main sponsor of this year's worldwide meeting, the BIM Week and the BIM Forum in Munich. And we are for more than 10 years active in developing of interfaces, not only to specific applications, but also we also support IFC format, for example. And this is a very important part of activity for our company. Also, on our website you find blogs, Facebook, Google+, where you get daily informations. If you look at the blog, you can see here there are interesting comments about projects, about useful features that you can follow. Yes, I think this is all I wanted to share with you today. As I said, if you don't know RFEM or RSNOB, or you would like to try out the interface, maybe one more thing, you can download the trial version from our website. It's free. It runs for 30 days. And you have here also the website for first steps that gets you started. We find here tutorials, introductory videos, and so on. Please stay tuned in also with the webinars. At the webinars, you see here the webinar page, you see here there are many webinars that you can look at for free. You can just watch them, download them, and we will have also a regular webinar plan for next year. For this year, we have no more English webinar. The next one will be most likely in January next year. Please stay on our website and you will find there invitations and information when they start. Thank you for joining us today. Thank you for taking your time to see the presentation. I hope it was good invested time, and goodbye and have a nice day.